Find the vector equation of the line passing through 1, 2, 3 and perpendicular to this plane. See here, a plane is given. This is equation of plane. Normal to the plane is vector I plus 2j minus 5k. This is normal to the plane. Now required line is passing from 1 to 3 and perpendicular to this plane. So perpendicular to this plane, so this will be the required line. It may be something like this. It is perpendicular. And this line is passing from 1 to 3. Suppose the point is here 1, 2, 3. Now see this diagram. Because line is perpendicular to plane, this vector n, which is a normal to this plane, is giving a direction of this line. So line is parallel to this vector. So here position vector of this point we take. Line is passing from this point, so vector A is 1i plus 2j plus 3k, and line is parallel to this vector, which is normal to this plane. So equation of line is therefore vector equation of line, vector r is equal to vector A plus lambda times vector n. Lambda belongs to r. That is vector r is I plus 2j plus 3k plus lambda times I plus 2j minus 5k. This is a vector equation of line. Now in this question, find equation of plane passing through ABC. Suppose that this plane is passing from ABC and parallel to another plane. Suppose this is a parallel plane. This is given plane. It is given. This is required. Now given plane, its equation is here. So this is normal to this plane. Normal means perpendicular. So normal to this plane, that is, can be taken in this direction or in that direction, any perpendicular. So suppose we are taking normal to this plane. So this is normal. It is vector n is I plus j plus k. Now see, this plane is parallel to this plane. Therefore, normal to the required plane will be same as normal to the given plane. So because planes are parallel, so their normal are same. Therefore, normal to required plane, it is same as normal of given plane. So normal of required plane is I plus j plus k. Whatever is perpendicular to this plane, same will be perpendicular to this plane. If this is vector n, same will be n. This is n. Because these planes are perpendicular. So vector n is I plus j plus k. And here plane is passing from ABC. So that point we are taking vector A. Vector A is AI plus BJ plus CK. That is position vector of a point through which plane is passing. So equation of plane is therefore vector equation of plane is vector R minus vector A dot vector n equal to 0. That is vector R minus vector A, that is AI plus BJ plus CK dot vector n is I plus j plus k is 0. We can also find its Cartesian form. This can be converted into Cartesian form. Our Cartesian equation is this was vector equation. So Cartesian equation is 1 into x minus a. So 1 into x minus a plus 1 into y minus b plus 1 into z minus c equal to 0. I have taken dot product of these vectors, where vector r is xi plus yj plus zk. So that is x plus y plus z is equal to a plus b plus c. So equation in Cartesian form also can be found by this way. Find the coordinates of the point where the line through 516 and 341 crosses the YZ plane. Say here, if this is YZ plane, if it is YZ plane, then every point on YZ plane has x coordinate 0. Say we are doing everything in coordinate axis in 3 dimensions, x, y, z. So this is YZ plane. In 3 dimensions you can imagine like this YZ plane. Surface of blackboard is XY plane, YZ plane, and flooring is XZ plane. So on YZ plane every point will have x coordinate 0. From any point on YZ plane, if you take perpendicular on x axis, then x coordinate of this point is 0. From this point, if you take perpendicular on x axis, say this is perpendicular to x axis, this is perpendicular to x axis. Taking perpendicular from any point on YZ plane, thought of perpendicular always go at origin. So every point on YZ plane has x coordinate 0. Coordinates of any point on YZ plane are like 0, BC. Blackboard is XY plane. If blackboard is XY plane, then this is Z axis, then YZ plane is perpendicular to this surface of blackboard. So it is like this. This is YZ plane. So keep remember, every point on yz plane has x coordinate 0. Similarly, every point on xy plane has z coordinate 0. Every point on xz plane has y coordinate 0. So here a line which is from these 2 points is crossing this plane. Here line is crossing this plane, crossing yz plane. So whatever will be the point of intersection, its x coordinate is 0. Here x coordinate will be 0, x coordinate of this point, and line is passing from 5 1 6 and 3 4 1. So first of all we find equation of line passing through points 5 1 6 and 3 4 1 is, we use result to find equation of line if 2 points are given. So result was x minus x1 upon x2 minus x1 equal to y minus y1 upon y2 minus y1 equal to z minus z1 upon z2 minus z1. So that is x minus 5 by minus 2 equal to y minus 1 by 3 equal to z minus 6 by minus 5. It is the equation of this line. This means every point on this line, say any point P, variable point whose coordinates are x, y, z. So if you keep coordinates of any point x, y, z, if you put your value of x, y, z, that is coordinates of any point which lie on this line, then this ratio is equal, always equal. If you put your value of x, y, z, that is coordinates of this point or this point or this point, point must be on line. Coordinates of every point which lie on this line must satisfy this equation. For every point, ratio will be equal. Suppose that each ratio is lambda. We say lambda is any real. As you change value, as you change point, lambda will be changed. Every point on this line corresponds to unique value of lambda. So that means, so therefore we can say for some lambda, some particular value of lambda, point of intersection can be taken as minus 2 lambda plus 5 comma 3 lambda plus 1 minus 5 lambda plus 6. So here I use the word some lambda, particular value of lambda. For particular of lambda, value of lambda, point of intersection has these coordinates. If you change your value of lambda, if you take lambda 1 in this triplet, so you will get coordinates of this point. If you take lambda 2 in triplet, you will get coordinates of this point. If you put lambda 10, maybe this point. As you change lambda, every time you get a different distinct triplet. That means distinct point on this line. So when you will reach at this point, which is point of crossing, corresponding to this point, there will be some particular lambda that we don't know. So I use word some particular lambda. But point of intersection is whose x coordinate is 0, but line but here x coordinate is 0. That means minus 2 lambda plus 5 is 0. So lambda is equal to 5 by 2. So if we keep here lambda 5 by 2, then we get point of intersection with YZ plane. So therefore point of intersection with YZ plane is equal to, putting here 5 by 2, x coordinate is 0, putting here 5 by 2, so 15 by 2 plus 1, putting here 5 by 2, so minus 25 by 2 plus 6, that is 0 comma 17 by 2 comma 12 minus 25 minus 13 by 2. So this is a point of intersection with YZ plane. In question, if you are given here XZ plane, if XZ plane, take Y coordinate 0. If here XY plane is given, keep Z, take Z coordinate 0. So whenever we want to find point of intersection of line with a plane, we perform this procedure and then we define some particular lambda for point of intersection. One more question on similar method. Find coordinates of point where the line through these 2 points cross this plane. Here equation of plane is given. So here suppose this plane is, equation of this plane is 2x plus y plus z equal to 7. There is a line which cuts this plane and this line is passing from 2 points are given, 3 minus 4 minus 5, and the second point is 2 minus 3 1. Line is passing from these points and it cuts this plane. Suppose somewhere here, this is point of intersection. We want coordinates of point of intersection. So to find point of intersection, similar beginning. First of all, equation of line, equation of line passing through 2 points, 3 minus 4 minus 5 and 2 minus 3 1 is, using a 2-point result, equation is x minus x1 upon x2 minus x1 equal to y minus y1 upon y2 minus y1 equal to z minus z1 upon z2 minus z1. That is x minus 3 by minus 1 equal to y plus 4 by 1 equal to z plus 5 by 6. So this is equation of this line. That means if P is any point whose coordinates are x, y, z, if you put here coordinates of any point from this line, then this equation will be satisfied. Putting coordinates of any point, each ratio will be equal. Suppose that each ratio is lambda, where lambda belongs to R. Now we define point of intersection. So for some lambda belong to R, point of intersection point of intersection will be equal to, say, x coordinate. X coordinate is minus lambda plus 3. So 3 minus lambda. Y coordinate is lambda minus 4. Z coordinate is 6 lambda minus 5. Lambda is any real. Say, meaning of this a point is that as you change value of lambda, every new value of lambda gives a new point. Suppose if you take lambda 1, so suppose you are getting this point. Take lambda equal to 2, you will get this point. Take lambda equal to 3, you will get this point. So when you come at point of intersection, this point is also related for some lambda, particular lambda. So we use word some lambda, and that lambda we need. Lambda corresponding to point of intersection we require now. And to find lambda, now what we do? Because this is a fixed, a point is defined, this is point of intersection. Already we have defined by some particular lambda, it lies on this plane. This point, if it is point of intersection, it lies on this plane, which lies on this plane. Now it is a point of a plane also. So coordinates of this point will satisfy this equation. So therefore, putting in this equation, 2 into 3 minus lambda plus y is lambda minus 4 plus z is 6 lambda minus 5 equal to 7. So that is 2 into 3 6 minus 2 lambda plus lambda minus 4 plus 6 lambda minus 5 is 7. Therefore 6 lambda plus lambda is 7 lambda. 7 lambda minus 2 lambda is 5 lambda. 6 minus 4 is 2. 2 minus 5 is minus 3. Take minus 3 on the other side. That is 7 plus 3 is 10. So lambda is 2. And putting here lambda 2, therefore point of intersection is equal to 3 minus 2 comma 2 minus 4. I am putting lambda equal to 2. 12 minus 5. So that is 1 minus 2 7. So this is point of intersection. Find equation of the plane passing through the point minus 1 3 2 and perpendicular to each of the planes x plus 2y plus 3z equal to 5 and 3x plus 3y plus z equal to 0. So here a point is given through which plane is passing. Point is given. We suppose direction ratios of normal to required plane are ABC. If direction ratios of normal to given plane to required plane passing through point minus 1 3 2 are suppose A, B and C, then its equation can be written as ABC are direction ratios of normal. This point is x1, y1, z1. So by result, A into x minus x1 plus B into y minus y1 plus C into z minus z1 equal to 0. That is, Simplifying this, ax plus by plus cz plus a minus 3b minus 2c equal to 0. Now, so this will be a required equation. Let me say it is equation 1. Now it is perpendicular to these two planes, x plus 2y plus 3z equal to 5 and 3x plus 3y plus z equal to 0. So it is perpendicular to these two planes. Now see, this is perpendicular to these two planes, therefore here ABC are direction ratios of required plane, and here 1, 2, 3 are direction ratios of this plane with which this is perpendicular. So a into 1, that is a into 1 plus b into 2, b into 2 plus c into 3 equal to 0, and this is also perpendicular to this plane. So dot product of their normals is 0. So I am taking dot product of normal, a into 3 plus b into 3 plus c into 1 is 0. Therefore we are getting two equations, a plus 2b plus 3c is 0, this is equation 2, and 3a plus 3b plus c equal to 0, this is equation 3. Now we solve these equations, we solve for to get value of small a and small b. So what we do, I am multiplying this equation 2 by 3 and then I will subtract 3. Equation 2 multiplying by 3 and I will subtract 3. So we solve equation 2 and 3. So equation 2 and 3, say equation 2 I am multiplying by 3, so 3a plus 6b plus 9c is 0. First equation is multiplied by 3. Then second equation I keep as it is, 3a plus 3b plus c is 0. Now taking subtraction, say here minus minus minus, this is cancelled. 6 minus 3, 3b plus 8c is 0. Therefore here 3b is minus 8c. So b is minus 8c by 3. I have obtained value of b in terms of c. Now this value I am putting in equation number 2. So a plus 2 into b plus 3c is 0. So we will have value of a in terms of c. Therefore a minus 16c by 3 plus 3c is 0. So a is 16 by 3c minus 3c. 16c by 3 minus 3c. So a is 16 minus 9, 7. So this is a. So putting this value in equation either 1 or we can also put in this equation. Let me say this is equation 1. This equation and this equation both are same. But to calculate easily, we use this first line. So putting this value in equation 1. So putting in 1, A is 7c by 3 into x plus 1 plus B is minus 8c by 3 y minus 3 and C keep as it is, C plus C into z minus 2 equal to 0. See, these are two equations in ABC, and we have solved these two equations in such a way that we have solved for A and B and values are in terms of C. So C is C. If C is C, A is minus 8C by 3, B is minus 8C by 3 and A is 7C by 3. So these values we have taken in equation 1. Now dividing this equation by C, say C is common. So dividing by C, 7 by 3 into x plus 1 minus 8 by 3 into y minus 3 plus z minus 2 is 0. That is 7 into x plus 1 minus 8 into y minus 3 plus 3 into z minus 2 is 0. That is 7x plus 7 minus 8y plus 24 plus 3z minus 6 is 0. So 7x minus 8y plus 3z, 7 minus 6 is 1, 1 plus 24 is 25. So this is required equation of plane. If the points 1, 1p and minus 3, 0, 1 be equidistant from this plane, then find value of p. Say here plane is vector r dot 3i plus 4j minus 12k plus 13 equal to 0. In Cartesian form, this can be written as 3x plus 4y minus 12z plus 13 equal to 0. Now points 1, 1p and minus 3, 0, 1 are equidistant from this plane. This is given plane. So distance of this point from this plane is equal to distance of this point from same plane. So applying that formula, modulus of, see on left hand side, see RHS you set 0, already we have set 0. Now in left hand side we replace x, y, z by 1, 1p. So 3 into 1, 4 into 1 minus z is p plus 13 divide by square root of a square plus b square plus c square. On other side, distance from this point. So again similarly modulus of, now we replace x, y, z by these three numbers. So 3 into minus 3 plus 4 into 0 minus 12 into 1 plus 13 upon square root of plane is same. So 9 plus 16 plus 144. Therefore modulus of, say 4 plus 3 7, 7 plus 13 20, 20 minus 12p is equal to, this is minus 9 minus 12, so minus 21, minus 21 plus 13, so minus 8. So this is modulus of minus 8. This will be cancelled. 13 minus 12 is 1. 1 minus 9 is minus 8, modulus minus 8. So modulus of 20 minus 12 times P is 8. Therefore, 20 minus 12P is plus 8 or 20 minus 12P is minus 8. Therefore, 12P is 20 minus 8 12 or 12P is 20 plus 8. So P is 1 or here P is 28 by 12. So value of P is 1 or P is, this is divisible by 4. So 7 4s are 28, 3 4s are 12. So these are possible values of P. Find the equation of the plane passing through the line of intersection of planes. See here, equation of planes are given. Vector R dot I plus j plus k equal to 1. This equation in Cartesian form can be written as 1x plus 1y plus 1z minus 1 equal to 0. This is given equation in Cartesian form. And other plane is r bar, vector r dot 2y plus 3j minus k plus 4 equal to 0. This implies 2x plus 3y minus 1z plus 4 equal to 0. This is second equation of second plane. Now required plane is passing from intersection of these two planes. So equation of plane passing through intersection of planes 1 and 2 is by result x plus y plus z minus 1 plus lambda times 2x plus 3y minus z plus 4 equal to 0. So you can remember, whenever we use this result, here RHS must be 0. This part we keep in bracket, then plus with lambda we keep this second LHS for some lambda belonging to R. This is particular value of lambda. For a required plane there exists particular value of lambda. So this equation can be written as 1 plus 2 lambda times x, 1 plus 3 lambda times y, 1 plus 1 minus lambda times z plus 4 lambda minus 1 equal to 0. So this is equation of required plane in lambda form. Now it is a parallel to x-axis. This plane is parallel to x-axis, which is parallel to x-axis. That means, say, this is x-axis, this is y-axis, this is z-axis. When plane is parallel to x-axis, that means suppose it may be like this. This is parallel to x-axis. So when plane is parallel to x-axis, its normal will be, if you take normal, then normal will be perpendicular to x-axis. Say, you have to imagine in space, Parallel to x-axis, that means if this line is x-axis, then it is not like that plane is always like this. It can be in cross. If this line is x-axis, parallel to x-axis, that means keeping some particular distance with this line. If you move your palm around this line at 360-degree rotation, then see this is the plane parallel to x-axis. This is the plane parallel to x-axis. Here this is the plane parallel to x-axis. In diagram I have shown such plane parallel to x-axis. So if you take any plane parallel to x-axis, and if you imagine is normal, then normal will be perpendicular to x-axis. If plane is like this, normal will be like this. If plane is like this, normal will be like this. But every time in 3 dimension, it will make angle 90 degree with x-axis. So parallel to x-axis, therefore normal to the plane it will be, this is normal, is perpendicular to, it will be perpendicular to x-axis. So therefore vector along x-axis and this normal, dot product of these two will be 0. Therefore if we say vector n is 1 plus 2 lambda times I plus 1 plus 3 lambda times j plus 1 minus lambda times k. Here from this equation ai plus bj plus ck, this is normal to this plane. So normal is perpendicular to, let me take a unit vector in the direction of x-axis, unit vector, it is I cap, this is direction of x-axis. So therefore vector n dot I is 0, therefore see 1 plus 2 lambda into 1 is 0. Here I cap you can consider as I plus 0j plus 0k. So 1 plus 2 lambda into 1 is 1 plus 2 lambda. This number into 0 is 0. This number into 0 is 0. That's why we keep only non-zero value. 1 plus 2 lambda into 1 is 1 plus 2 lambda. So this is equal to 0. Therefore lambda is minus 1 by 2. Putting this value of lambda minus 1 by 2 in this equation, so putting in 3, we can put in 3 or we can put in this equation or in this equation. Same, we can also put in this equation. So putting in 3, 1 plus 2 lambda is, see 2 lambda is minus 1, so this will be minus 1 into x plus 1 plus 3 lambda that is minus 3 by 2, 3 into lambda minus 3 by 2 y plus 1 minus half that is plus half z plus 4 into lambda, so 4 into minus half that is minus 2 minus 1 equal to 0. So that is equation is free from x. So this will be minus 1 by 2 y plus 3 by 2 y, 3 by 2 z minus 3 equal to 0. Multiplying by 2, So it is minus y plus 3z minus 6 is 0. Now changing sign here, y minus 3z plus 6 is 0. So remember, if a plane is a parallel to x-axis, equation is free from x. If plane is parallel to y-axis, equation is free from y. So whenever any required plane is parallel to any coordinate axis, this is the method to find equation of plane.